Exception: treating dependent events and independent. Some cumbersome calculations can be greatly simplified by using the common practice of treating events as independent when small samples are drawn without replacement from large populations. In such cases, it is rare to select the same item twice. So here's a common guideline routinely used with applications such as analysis of survey results. Now, treating dependent events and independent. 5% guideline for cumbersome calculations. When sampling without replacement and the sample size is no more than 5% of the size of the population, you treat the selections as being independent, even though they are actually dependent. So let's take a look at example 5. Drug screening and the 5% guideline for cumbersome calculations. In a recent year, there were 130,639,273 full-time employees in the United States. If one of those employees is randomly selected and tested for illegal drug use, there is a 0.042 probability that the test will yield a positive result, indicating that the employee is using illegal drugs based on data from the Quest diagnostics. Now assume that 3 employees are randomly selected without replacement from the 130,639,273 employees in the United States. Find the probability that the 3 selected employees all test positive for drug use. Now, because the 3 employees are randomly selected without replacement, the 3 events are dependent. But here, we can treat them as being independent by applying the 5% guideline for cumbersome calculations. The sample size of 3 is clearly no more than 5% of the population size of 130,639,273. Therefore, we get the following. The probability that all 3 employees test positive is equal to the probability that the first test positive and the second test positive and the third test positive. So now we're going to write it as the following. The probability that the first test positive times the probability that the second test positive times the probability that the third test positive. Now, what is the number that's associated with that probability? Well, the probability is 0.042. So we take 0.042 times 0.042 times 0.042, and therefore we get the following value, 0.0000741. Therefore, we would say that there is a 0.0000741 probability that all 3 selected employees tested positive. Now, in this example, if we treat the events as dependent without using the 5% guideline, then we would get the following cumbersome calculation that begins with 130,639,273 employees. That means with the 4.2% of the following, that means you're taking 0.042, multiplying it by that value, which is 130,639,273, which then gives us the value of 5,486,848 testing positive. So what we would do is the following. We would take that number, divide it by the total, times, again, that number divided by the total, times that number divided by the total. Multiplying that all out gives us 0.0000740879. If we round that that 0 digit, we would get 0.0000741. Now, just imagine randomly selecting 1,000 employees instead of just 3, as is commonly done in typical polls. Extending this above calculation to include 1,000 factors instead of 3 factors would be very cumbersome, which is the reason why we use that 5% guideline for cumbersome calculations. Now, caution: in any probability calculation, it is extremely important to carefully identify the event that's being considered.